Once again, welcome to this session. In this session, we basically just want to look at the quantum numbers. Of course, why we are doing this is because we need to understand that the electron in an atom, it is not easy to find an electron at the same spot. Okay, so it is basically related to some location, and of course we'll be talking about some energy levels where exactly we are able to find an electron in an atom. So now, when you talk of quantum numbers, these quantum numbers will tell us exactly the energy level that the electron is occupying. Okay. Secondly, these quantum numbers, of course, will also tell us the shape of the orbital. Okay, where it is found. It will also tell us the orientation, in what orientation is this electron orbiting at. Lastly, these quantum numbers will tell us also about the spin. Is that okay? So it will tell us about four things: the energy level, the shape of the orbital, the orientation, and of course finally the spin of the electron. Is it spinning up or is it spinning down? So to begin with, take note, we are saying we should understand that an electron in an atom has some location, some location relative to the nucleus, has some location relative to nucleus and energy. So this is the common thing: the location where it is found, and of course the energy level it is occupying. So now we need to understand that the probability of finding an electron at a certain point is commonly known as the orbital. So we are saying, instead of the probability, we are saying the region. So the region of space in which, so this is the space in which the probability of finding an electron is high, is called orbital. So this term, maybe we'll be using it at an orbital. So what we mean, an orbital is basically the space where we expect to find an electron, and that space is basically maximum. What we mean is that the chances of us finding an electron in an orbital is very very high. Is that okay?
Yes.
Therefore, these quantum numbers these quantum numbers they describes energy, okay? They describe the energy, the shape of the orbital, okay, the orientation, and finally the spin. So these quantum numbers will describe the shape, will also describe the energy level, the orientation, as well as the shape, the spin of an electron. Now, what are these quantum numbers? So there are 4 quantum numbers that we need to look at. Number 1, we have got the principal quantum number. So the principal quantum number is given by symbol n. So this generally will talk about the shape, the energy level. So the first one is the principal quantum number. So what is the principal quantum number? So the principal quantum number determines the energy level of an electron. So this one, it determines the energy level of an electron. Now when you talk of energy level, so the energy level will start from n value of 1. So you can't have 0 energy level, it means the atom doesn't exist. So you should take note that the n values, they start from 1, 2, 3, 4, all the way to infinity. They start from 1 all the way to infinity. Now we should understand that the higher the energy level, the bigger the atom, or the furthest the electron stays away from the nucleus. So now what we mean is that the n value represents the average distance of an atom. So it represents the average distance of an electron from the nucleus. So if this is what you mean, if the n value is too big, it means the electron is further away from the nucleus. So the most inner shell, or the most inner orbital, is the one that will have n is equal to 1. It means this is the one which is so close to the nucleus. So the most inner orbital has n is equal to 1, followed by 2. So now these values, what they represent is that if n is small, it means it is close to the nucleus. Is that okay?
Yes.
We should also take note that the maximum number of electrons in each energy level is given by so to get the number of electrons, so number of electrons is equal to 2n squared. 2n squared. So now what it is that if n is equal to 1, meaning this energy level will have the maximum electrons will be 2n squared, which is 1 squared. So meaning when n is equal to 1, the maximum number.
Repeat a bit on the number of electrons there.
Okay, so I'm saying the maximum number of electrons that any energy level can accommodate is given by 2n squared, where n is equal to the energy level or principal quantum number. So if the principal quantum number is 1, it means you just substitute here and calculate where there is n, you put 1, you are going to have 2, which means when n is equal to 1, this one will have the maximum of 1 electron. 2 electrons rather. So if n is equal to 2, the maximum number of electrons. Yes, please.
So like here, let's say n is equal to 1. We don't use that formula for where you use the constant.
No. Here you just want to know how many electrons will be there. For red.
Okay, so like in such situation, you only be given like 6. For n, you only be given like 1, because that's one for the constant. Like they provide 2 for n1 and n2.
Yes.
So like this one, they only give you one value for n1.
No. Here you just want to know the maximum number of electrons.
Well, that one is calculating wavelength, right?
Yes, that one is for wavelength. Here you just want to know how many will be in each energy level. So if we are saying if the electron, how many electrons can the energy level of 1 occupy? So we are saying the first energy level only occupy 2 electrons. Do you even remember that where you used to draw this back in the days? The electron configuration.
That one is for the electron, but I still don't know, because like back in the day we used to draw the pharmaceutical. Now it's different. Now we use 1 AC, 2S, or 2, and again.
This is what I'm saying now. Remember when we said the first shell here can only accommodate 2 electrons?
Electrons, and the second one is 8.
So let's see. This is the formula they used to use to calculate. So if it is in energy level 2, again you do substitute here 2 squared here. What are you going to have? 8. That's why we used to have 8 electrons in the second shell. Remember? So that's what we mean. Each energy level will have the maximum number of electrons it can accommodate. So understand that the values for energy levels start from 1, 2, and principal quantum numbers will tell you about